I'm here with Jan on the Maxwell Technologies booth. Jan, in your presentation yesterday, you started out by defining the difference between energy and power. Why is that important?
Yeah, it is actually very important. I started also my presentation with telling that there are different tools in the grid actually to cover some of the problems which are existing. And some problems are related directly to energy, some problems are directly related to power. When we're talking about the energy, most electrochemical storage technologies like batteries, they have very high energy content, so
Correct.
they can provide energy for a longer time duration, but they are actually having some kind of issues with high cycling, and they are directly related to thermal events, and that is actually bringing the limits of capabilities of batteries.
Okay.
The total opposite of that technology is ultracapacitors. It's an electrostatic charge and discharge process on cell level integrated into large-scale systems, and they have an extreme high power density. And since it's electrostatic, they have the capability to run millions of cycles and have a very long lifetime because they have no chemical degradation. And exactly this is covering power problems in the grid, while batteries do the energy problems, and in conjunction or standalone, they work very well together.
So they're complementary.
Yes.
Now, many people may not have seen a capacitor like this before, so this is one of your ultracapacitors? What am I holding here?
Yeah, correct. No, we are here on this conference. Many people see ultracapacitors still as innovation. I think that what we want to really show here is that these products are existing. They're existing since a very long time, and the technology actually is quite basic. So it's an electron. The electrode is based on carbon.
Yep.
It's winded up with a separation paper in between.
Right.
There are some physical processes inside that create the very high capacity.
Right.
And then it's an electrolyte. And these components are put in a hermetic sealed cell, which is also directly related to the safety and safe operation of these cells.
Right.
And they are very well high volume manufacturable, so they can be built easily in manufacturing lines in millions and millions and millions.
And then I take numbers of these and I build them into some sort of a module like you have here?
Exactly. So we are actually present in several industries, and the end user normally does not have big benefits if he's just taking the cell.
Right.
So we make it as easy as possible to integrate cells into modules. We combine them with electronics, with monitoring and balancing of the cells inside, also for safe and long life reliable operation. And we try to tackle actually the markets with the right modules to make it as easy usable as possible. What we're seeing here is our grid cell pack.
Okay.
That combines 24 of these cells with the leanest way of integration, so you do not see too much exterior material around it.
Correct.
Combined with electronics, which provide the monitoring and the balancing in a very advanced system. It would probably go too deep to explain it, but it allows good operation and always visibility on the performance and the status of the system.
And then if I'm deploying this into the grid to address some of the power issues, then I take a number of these, and this is where the unit over here comes in?
Yes. So the small cell pack that we have just seen, that is normally directly related to systems what we would consider up into the 1 megawatt range, maybe a little bit more or less, and it is very flexible. Now when we're looking into very large scale systems, and they can easily go up to 100 megawatt systems, then obviously we go a step further for easy integration. So we have designed this type of module in conjunction with a worldwide operating system integration company.
Right.
And actually to meet all the industrial standards for utility scale applications. So we have all the redundancies required in communication, the monitoring and the balancing system is laid out so that really on large scale systems, the operator always has chance to know the secure state of the system.
Right.
10 modules come with a so-called gateway or cabinet gateway. We have the chance directly over optical fibers and different communication protocol optional.
For remote management.
Remote management, but also directly to integrate into grid scale controller systems.
Of course, because you're looking at millisecond response times, right?
Absolutely. And we have current sensors included. And so recent applications have shown for frequency response, and I also explained it in my presentation yesterday that the very, very important initial response to frequency deviations are from milliseconds up to several seconds.
Yep.
And since sizing is possible, very precise with this type of power storage on the spot, you can design a system which exactly covers the need in time duration to the smallest footprint and most economic beneficial solution at the end. So the application that I talked about yesterday is a 50 megawatt 10-second application for primary frequency response, and that comes into an installation where 200 of these racks are installed.
200?
Yes.
To give an idea of the scale.
To give an idea of the scale. If you would try to cover the same with a battery system, you would come to 5 times higher in footprint, and you would have energy for maybe half an hour, even an hour on your shoulder, what you normally do not need in a standby or standalone application, which is only determined for short durations.
Wow. Thank you very much. Fascinating.
Very welcome.
Thank you.
Yeah, thank you.